Hello, everyone. Welcome to another day in the series of our CSEC workshops. If you're joining us for the first time, hi, hello, welcome. You've missed a few, but they're on YouTube, but you can always go and watch them. But welcome, and if you're coming back and you would have been here before, everyone, welcome to another day. Sorry about that. Right, so if you are just joining us, hi, hello, welcome. We have more coming, so you want to stay tuned so you can come back. And if you're coming back, welcome back. Today, myself, Latoya Shiraya, and Mrs. Claudia Interwinter will be taking you through bearings, right? So have your questions ready for us and get ready to learn with us. All right, so by the end of this session, we're hoping that you are able to determine the relative position of one or 2 points given the bearing of 1 point with respect to the other, as well as solve problems involving bearings. So, what is a bearing? I need you to talk to me now and type it in the chat. What do you think a bearing is? What's a bearing being referred to? Type your answers in the chat and tell me, okay? When you hear the word bearing, what's the first thing that comes to mind?
Latoya, I'm seeing where Shane says direction.
All right, got that. Anybody else? You thinking?
Rihanna said your location.
Okay. I'm gonna give the others 30 more seconds. I think they're thinking, so I'm gonna give them a few seconds to think and type their answers.
Abigail type is an angle in degrees measured clockwise from south.
Oh, wow. Okay, Abigail, I see you, girl. All right. So we heard direction, we heard location, I heard angle, and I heard from south, right? Okay. By the time we're through with this presentation, I'm going to ask you the question again, and you can give me a more precise, refined definition. I won't say if you're right or you're wrong, but you will know whilst we're going through, right? Now on screen, you are seeing an image or 2 images actually. And this is what we call a compass. Now, the compass is used to tell direction. Before we got into this modern age, and we had GPS on our phones and Google Maps or GPS in our cars, persons had to use compasses to get around, right? Especially those ships and pilots and those who would go out into the woods or wherever to travel and explore, those explorers. But how does this compass thing work? How does a compass work? I'm going to show you a video of how the compass actually works. So on screen, you're seeing somebody with a compass in their hand moving around. And as you can see, the hands on the compass is actually moving as the person is moving. So as the person moves, their direction will change, and so would the compass too, because the compass is telling you the direction that you're moving in, right? So imagine not having Google Maps or any GPS to help you, and you would needed to get to somewhere, you don't know where you are going, and you had to use this device, this compass. You think you would be able to manage just doing this every time you don't know how you to find somewhere that you're going? I'm so happy for GPS. I don't know about you, but I'm very glad for Google Maps and this GPS. All right. So here we have, what's happening? So okay, I don't remember the name. I think we heard direction. Abigail made mention of angle. She made mention of, I think she did made mention of clockwise. She made mention of south. Two other persons made mention of location and direction, right? So when we talk about bearings, we're talking about a measurement from north, actually, in a clockwise direction, and it is usually written or always written as 3 figures. So as you're seeing on screen, being represented, north is either 360 degrees or 000 degrees. So we wouldn't just say 0, but we would say 000 because it is being represented in 3 figures. East automatically, as east as possible, would be 090 degrees, 090 degrees, south 180 degrees, and west 270 degrees. Now, I'm not sure, I hope you're seeing that little point there being represented on the circumference of the circle. And I need you to give me an estimate of what you think the degree of turn to that point would be, or the bearing would be at that point. Type your answers in the chat. So what do you think the bearing would be if I were to get to that on the circumference of the circle, right above east?
I'm getting some responses in the chat, Latoya. So Ryan is saying 45. Yandra is saying 54 degrees. And she changed her mind. Did you change your mind, Yandra? You're saying no, 45 degrees? And she said she did change her mind, and Shane is saying 45 degrees.
All right. I'm happy that Shane changed his or her mind. I'm happy. I'm happy that you saw that you did not represent it as 3 figures, and now you're changing your answer. I love that. All right, let's see.
Alicia is saying 60 degrees.
All right, let's see.
All right, and there are more responses. Let us check the answer.
So it's approximately about 60 degrees, 60 degrees actually, even though we have 60 on screen, that should be 60 degrees, right? Remember it's an approximation, but let's just look at where the angle is formed for a minute, right? It's a little bit, remember, from north to east would be 90 degrees. It's a little bit past the half mark, so it would be a little bit more than 45 degrees for those who were saying 45, right? Okay. All right. So taking the first image, that's the one that is most right. How would you, what is your estimation of the point on the circumference on the circle? Just type your answers in the chat. So that point is now nearer to south. How much do you think this angle is measuring, or what is the bearing of that point? Remember, we're looking for an angle value. That's okay. And I hope you noticed from the first image the direction in which the arrow is going. And as you are seeing at the top left-hand corner of your screen, we're measuring from north in a clockwise direction. I hope you noticed that. So we're talking about bearings. We have to start at a north point, and we're always moving in a clockwise direction. And of course, you're representing our angle in 3 figures. Any responses in the chat, Mrs.
So Alyssa is saying 150 degrees. Ryan is saying 145 degrees. And Shane is getting very precise. He's saying 157 and 5/10 degrees. Michaela is saying 150 degrees, and DeAndre is saying 140 degrees.
All right, let's see.
Let's check the first one.
Starting from north in a clockwise direction. So it's an estimate, guys. Remember, it's an estimate. So it's about 145 degrees. The second one, quickly. How much, what's the angle there? Remember, we're looking at the bearing and we're starting from north in a clockwise direction. And this point on the circumference is nearer to west, but not so far from south.
Alicia is now saying this answer is 225 degrees. And Shane is now saying it's 240 degrees. Another response is saying 230 degrees. Another student just concur with what was said before. Alexia said 225 degrees. And Shakira is saying 230.
All right, let's check. So if you had 230 to anywhere between, I'm going to say between 225 degrees and about 235 degrees, we'll take it, right? Remember, it's an estimate. So for those who said 230 is spot on, good job. Anywhere near there, it's fine as well. All right, and let's take the last one. What is your estimation for this last one? It's nearer to north, but not so far from west. I see we have some really good mathematical students here with some really good answers.
Yes.
Very good on the.
So I have a few responses. Latoya, I'm seeing Delanjo saying 335 degrees. Micah is saying 240 degrees. Shakira is saying 245 along with Ryan.
Okay. All right.
And Shane is also agreeing with the answer before.
Okay. All right. Let's check. So it's about 315 degrees. If you had an answer near there, about 5 degrees before or after, we'll take it. All right? Here we have some other points. And I think at this point, we're going to be using a compass, a protractor, sorry, a protractor. And we know that a 360 degrees protractor is used to measure bearings. That's what we usually use to measure our angles. So, from looking at the protractor and actually now measuring and not estimating, we're going to be looking at what each point actually measures. So the measurements will come in and you can just look and observe. So that first point, we're having 0-20 degrees, 0-45 degrees. All right, can somebody tell me, look on the compass now and tell me what will that next point measure? What's that other point measuring after the 110 degrees? That point measuring.
So the chat is buzzing and I'm seeing DeAndre saying 140 degrees. I'm seeing Shane saying 135 degrees. Davia, Ryan, and Micah is also saying 135 degrees.
All right, let's see. It was actually 135 degrees. All right, how about the next point that's right after south, to the left of south? What is that point measuring?
Ryan is saying 210 degrees. Trishan is saying 210 also. And Delan George agrees. And Shane also agrees.
All right. Let's see.
And Ashanti also agrees.
All right, so that's actually 225 degrees. Good job, guys. I'm seeing in the chat where persons were saying 210. Guys, remember your degrees, and it's not just a number. Don't forget your degrees, your unit of measure.
Latoya, the answer is 210. I just went ahead to the other one.
Oh,
so the answer is 210.
210, my bad, 210. 210. I think persons engaging on YouTube, I see you guys. Good job. All right. And then the final point. Let's get the final. Oh, no, there are more.
Let's go to the final one. And
Okay. Okay, so here, final point. What's the measurement for the final point? Very close to north.
Remember, we have a few persons saying 350 degrees and 345. So most persons are saying 350 degrees.
All right. Let's see. For those who are just joining us, remember we're looking at bearings, right? And when we are measuring the angle value for bearing, we start at north and we go in a clockwise direction. So for those who said 350 degrees, and I'm seeing Shanice Williams on YouTube who said 350 degrees. Go Shanice. Shante saying 345. Just a little off, Shante. All right. Now, when we're measuring now the bearing of one point from another, for example, to find the bearing of B from A, and I need you to zoom in to that statement. So we're finding the bearing of B from A. Yes? So our starting point would then be what? What would be our starting point? Type your answers in the chat. Where would our starting point be?
I'm seeing Shane, Shakira, Shanti, Alexia, Abigail, Brian. I say in A.
All right. So the first thing we do is draw a straight line segment between both points. There's a line segment. Now, because as you said, we're starting at A, we're going to draw a north line at A. Because when we measure bearings, it is from a north and we go in a clockwise direction. So we have to draw a north line at A, indicating a north direction there. And then we measure the angle between that north line and the line segment that we would have drawn connecting the points. Using our protractor to measure. And the bearing from A would be 060 degrees. All right? Very important to identify your starting point. Now we want to find the bearing of A from B. Where is our starting point?
They're all agreeing that the starting point is in fact B.
Fabulous. So what are we going to do next? We've identified our starting point, so we are now going to draw a line segment to connect both points. After we would have drawn the line segment, what's the next step? North line. Yes, Deandra. Where am I putting that north line? At B, because B is our starting point. Can I get an estimate for this bearing from B to A? Give me an estimate, a quick estimate. All right, I'm seeing some responses for the estimate. All right, let's check and see. So the bearing of A from B, remember we're going in a clockwise direction, is where's my answer?
Answer at the bottom at A, saying 240 degrees.
Okay, great. 240 degrees. All right. So I hope there are some very key points that we discussed just now, and we're going to solidify those points. So a bearing is a way of defining direction as an angle measured from due north in a clockwise direction. So there are some keywords there. North, clockwise direction. We always start at a north point and we always measure in a clockwise direction. All right? What is the bearing of B from A? And it's always important to be able to identify our starting point. Where are we starting and where are we going? Your starting point is where you will indicate your north line. So I'm seeing that I see A to B in the chat. Excellent. So we're starting at A and we are going to B. All right. So the first thing we do is connect our points. And then we draw our north line. And then we simply measure from our starting point. All right. So the bearing of B from A is 063 degrees, and we always represent our bearing in 3 figures. In other words, if you are at A and facing north, by how many degrees must you turn in a clockwise direction until you are facing B? All right. So what is the bearing from from B? And we would have gone through this just now previously. So of course, our starting point is B. And so our north line will definitely be at B. I'm seeing in the chart, B to A, excellent. And so in other words, you are at B facing north. By how many degrees must you turn in a clockwise direction until you are facing A? So you want to think about bearings like that. And you can undo the movement, you know. So standing facing forward, you want to get to a particular point and you make a clockwise turn. And that would be your angle. And so from B to A, or of A from B, that would be a bearing of 243 degrees. No. Here's a question for you, and I need you to type the answers in the chat. My friends over YouTube, I'm looking for your response as well. How do these bearings relate to each other? How does the bearing from A to B and the bearing from B to A relate to each other? Are you seeing anything coming out that you would have already done in some other aspect in the mathematics curriculum?
I see Micah saying co-interior.
What about the co-interior? I don't know what that means. What about it? Okay. I see Deandra says that they form a Z. So what about that, Deandra? The form a Z. So what? What do you know about Z's being formed? All right, Shakira, I see you. You're saying that they are corresponding. Okay. Know that the north lines would have been extended. Are you seeing anything happening there?
Shane is saying alternate angles.
Okay.
Davia is saying angle of depression or angle of elevation.
All right. Okay. Seeing some responses coming in. Love that. All right, let's see. What's happening, Miss? I don't remember who said Z angles, but the formal name for the Z angles are alternate angles. But what about the alternate angles? Go on, Miss. All right, so, oopsie. All right, so to get the bearing backwards, meaning you went somewhere and you're going back, we try to get an angle between 0 degrees and 360 degrees by adding or subtracting 180 degrees. So if you look at the bearing from B to A, you are seeing where that bearing from A to B would have been formed, and we would have just added 180 degrees to get back to B if we wanted to move from A to go back to B, which would have given us our bearings. That would be that 63 degrees rather, adding 180 degrees, and that would have given us our bearing. Are you seeing that? So if you were only given the bearing from A to B, and you were asked to find the bearing from B to A, then you could simply add or subtract, depending on the situation, 180 degrees to that bearing, and you would get your backward or return journey. So, all right, we've spoken a lot. Let's do a little, let's put into practice what we would have been talking about a little more. What is the bearing of X from Y? So here we have an image, and we want to know what is the bearing of X from Y. So where is your starting point? Where are you going? And what is that bearing?
In the chat, could you explain your answer, please, so we can say the process of how you arrive at your answer? I'm seeing where they're saying that you are at Y and you're going to X. So you're starting at Y.
Fabulous.
Shakira is saying 60 and Ryan said 120 degrees. Angle on a straight line. So Brianna wrote So 180, so yes, degrees. And so she took 120 degrees from 180 degrees and she got 60 degrees.
Nice. I'm also seeing on YouTube where I'm sorry if I mispronounce your name. Kevon Bernard did that too, where he took 120 from 180 to get 106 to get 60, sorry.
And Trishan is saying starting from Y, then subtract 120 degrees from 180 degrees, and I'm assuming that you say your answer will be 60 degrees.
All right, let's check and see. I'm loving the explanation, guys. Good job. And your responses would have been correct. And I did hear somebody's response of saying we're using angles on a straight line. That also works too. All right. What about the bearing of P from Q? Of P from Q. Where's your starting point and where are you going? What direction are you going in as well?
So Brianna is saying that she's subtracting 110 degrees from 180 degrees to get 70 degrees. And Micah is saying 0, 70 degrees. I think he's saying co-interior angles. And he did the calculation to get 70.
I want to give a special recognition to all the persons who are representing their bearing as 3 figures and not 2. Proud of you. Love that. Love that for you.
So Regina is saying that we are starting at Q.
All right. Let's see. Let's see. Let's see.
And then Regina, maybe you want to remind them why you knew you're starting from Q.
Let's see the answer, teacher. So the answer is actually 290 degrees. Remember, we are going in a clockwise direction. We're starting at our north point. And if we start at our north point, we have a little bit of distance to go. Yes, or a bit of turn, angular turn to get to P. And so it would definitely have to be a little bit more than 70 degrees. Remember also we were looking at forming alternate angles, which you are seeing on screen, and using that backward journey to help us. So we would have just added 180 degrees to our 110 degrees. All right, quickly, what is the bearing of W from O? I'm seeing, boy, I don't know, is this, I'm assuming it's King Orthodox on YouTube who would have explained that you would add the 180 degrees to 110 degrees to get the 290 degrees. Remember your units, please. I'm seeing Shanisha March on YouTube also explaining how she would get her 290 degrees for the bearing. Good job, guys. All right. What
I have a few
about
answers here, and they are saying the answer is 310 degrees, and they're adding 180 degrees to 130 degrees. That's what they're
okay?
doing.
See,
But Davia is saying you're starting at O, and you're taking 130 from 360, so your answer should be 230.
interesting. Okay. Let's check and see. All right, so that's 230 degrees. And what do you think about that response, Mrs. Luther Winter, taking 130 degrees from 360 degrees to determine the bearing of W from O?
Based on what? Let me find her again. Let me just recognize Davia. Based on what Davia said, you're starting, I think it should have been, Davia was saying that you're, let me find the right one. You're starting at O because it says the bearing of W from O. That means the word from would tell you that you are starting from O, you are at O, you are facing north, you're going in a clockwise direction. So it means that if you do a complete turn to O, you would have done 360 degrees. That means you would have not gone all the way and would have stopped somewhere. So if you know where you did not go, you can calculate where you went by taking that amount from 360. So in fact, Davia, you would have done the right calculation. Knowing where you are and where you're going will give you a better idea of what to do. And the key word to look for is from. Tells you where you are, and the word off tells you where you are going.
All right, so we just want to send a special big up to you, Davia. Good job, girl. All right, what is the bearing of A from B now? So you can see the importance of being able to identify where you're starting from, where you're going, and using the information that you have to help you. We know that a complete turn is 360 degrees. We know this. Any responses for the bearing of A from B?
Micah is saying 130 degrees. And Donnie explained that what you're doing, you're taking 050 degrees from 180, and that's why you would arrive at 130 degrees.
I love when you type a little explanation so we know and we can see what you're thinking. I love that. All right, I'm seeing over YouTube where I'm going to assume again that it's King Orthodox is saying subtract 50 from 180 and that will give you 130 degrees.
But DeAndre is not agreeing over here, but DeAndre, you got 220 degrees. Could you explain or type in the chat how you got that answer, please?
I'm seeing Shanice Williams with the subtracting of the 50 degrees from 180 degrees too. Okay, Shanice from YouTube. See you, girl. All right. Let's check our answer, Miss, and see what we get. And indeed, we would get 130 degrees. Excellent job, guys. Excellent work. What about the bearing of K from H? The bearing of K from H. Where are you starting from and where are you going? What direction are you going in? These are the questions that you must ask yourself or bear in mind whilst determining the bearing of a movement.
So we have a few answers in the chat. So Micah is saying that he's gonna take in 133 degrees from 180 and get 0.47 degrees. Brianna is not agreeing, and she's saying that we are going to be taking 133 degrees from 360 to get 227 degrees. And Shakira and Donna is agreeing with Michael. And Regina is reminding you that you are starting from H and you're going to K.
I'm also seeing Kevin on YouTube saying subtracting 133 from 180. But Kevin, is that how we represent the bearing with 2 digits, Kevin? And Shanice, is that how we represent the bearing? If it's 2 digit, that's not a bearing. All right, Miss, let's check our answer. So indeed, the bearing of K from H would be 0.47 degrees, Kevin and Shanice. All right, quickly, what about bearing P from Q? You see, it takes practice, you know, and I don't want you to feel anyway if you didn't get it correct. It takes practice, and we're taking our time to go through to ensure that you get it. So what is the bearing of P from Q? Again, asking ourselves, where are we starting from? Where are we going? And what direction are we going in? That also helps you to decide, am I adding or taking away 180? Am I subtracting from 360 degrees? That also helps you to decide what is it that you're going to do.
I'm seeing here where Shakira is saying coming from Q to P, therefore you should subtract 68 from 360 and your answer would be 292 degrees.
Oh, wow. Okay. Loving the explanation. I'm seeing where it's popping up. Some persons are saying 112 degrees.
And somebody said what Micah said. That's awesome. Oh, you
What
know
is
what Micah said?
P from Q? Let's see, miss. What's the bearing of P from Q? I'm seeing 248 degrees. Let's
So
see.
somebody did say alternate angles, but I think based on what you did, you left out one step.
All right, so that would be 292 degrees. And I think we would simply subtract 68 degrees from 360 degrees, right, miss?
Yes.
Great. I'm seeing where Montana McLean on YouTube did subtract 68 degrees from 360 degrees and got 292 degrees. All right. What is the bearing of Z from O? Z from O. Again, students, you want to look at where you're starting, where you're going, what the degree of turn looks like. Is it a big degree of turn? Is it a small degree of turn? Am I going to use 180 degrees to help me? Am I going to use alternate angles to help me? Am I going to use 360 degrees because I know that's the angle of a complete turn to help me? What am I using to help me? Where am I starting? Where am I going?
And for the persons who are typing in the chat, please indicate where you're starting from and where you're going. And how do you know what word tells you or gives you an hint to indicate where you're starting from? Could somebody type that in the chat for the others to see, please?
The name's skipping me, but I'm seeing starting from O to Z somewhere there. Popping up. Okay.
So they're saying the word from tells you where you're starting from. For the persons who are not seeing it, if you look at it, the word from gives you an idea where you are starting from, and then you go in a clockwise direction.
And also the word off tells you where you're going, your end point. But I think it is more important for you to identify the starting to then determine where you're going.
So I had a few answers in the chat earlier, and Shane is saying that you're going to be taking 137 degrees from 360 to get 23 degrees.
Okay.
And Davy agrees, and Jesse agrees. However, KD and Shakira is saying the answer is 043 degrees.
Okay, I'm seeing on YouTube, Montana McLean is saying taking 137 degrees from 360 degrees to get 223 degrees. I'm seeing Bernard is where you're going. O to W. There's no W. Kevon is where you're going. I'm assuming you meant Z. And Kevon is also taking 137 degrees from 360 degrees to get 223 degrees. Beyonce from O and taking 137 degrees from 360 degrees. But I'm seeing where Shanisha March is adding 180 degrees to the 137 degrees to get 317 degrees. All right, let's see. So you should have taken 137 degrees from 360 degrees to get 223 degrees. Again, students, I'm seeing where some persons are not sure if they are subtracting from 360 degrees or if they are adding or subtracting 180 degrees. You have to look at where you're starting from, where you're going. So if you're starting from O and you're going to Z, if you were to go straight back to O, you would do a complete turn of 360 degrees. However, you didn't go that little 137 degrees portion there. And so you could say, okay, I didn't go that portion, so I can take out from the 360 degrees. So you have to be able to reason out what is being represented in the diagram. All right, and finally, what is the bearing of A from B? Again, where are you starting? Where are you going? What information can you use to help you? Are we looking at alternate angles? Are we looking at a complete turn to help us? What are we using to help us?
Micah is saying is going to take 48 degrees from 180 to get 132. Micah, could you give me the reason for your answer in the chat, please? And Davia is saying that you're starting from B to A.
All right, so I'm seeing Shanisha March again on YouTube saying you're starting from B. However, Shante Henderson is saying that we're starting from A to B. Are you sure, Shante? Remember, we can use the keywords to help us and how to know where we're starting from. We're going to look for the keyword from. And according to this question, it says, what is the bearing of A from B? Which means that our starting point is definitely B.
That's how Micah did answer to my question. He's saying that the reason why he did that operation was because of co-interior angle starting from B. Hence, that's why he subtracted from 180 degrees.
Okay. She, Micah is a she, miss?
Sincere apologies, Micah. It's a beautiful name.
All right, let's check our answer to see. So we're starting from B, heading on to A, and we are indeed taking 48 degrees from 180 degrees, which would give us 132 degrees. I see you, McLean and March on YouTube. I see you, Shanice. I see you. All right. But we're just going to do random questions. So no, man, we're gonna do C-set questions to ensure that when we book up or go in the exam, we know what a question type looks like because we would have worked it on the ministry's C-set workshop and we know what to do, right? So let's apply what we would have done just now to a C-set type question. So the diagram below, definitely not drawn to scale. Students, please do not take out your protractor in the exam and measure the angles. They are not drawn to scale, all right? So the diagram not drawn to scale shows the positions of 3 ports, P, Q, and R. Q is 80 kilometers from P. R is 100 kilometers from Q on a bearing of 066 degrees. We are also told that the angle PQR is equal to 54 degrees, and we should calculate the bearing of P from Q. Where are we going? Where are we starting from? Which bearing we need? Of P from Q. So we're starting where now, guys? Where are we starting from? Love that.
Regina is saying Q.
Love that. Love
They're
that.
all saying Q.
Love that. Love that for you, Michaela. Love that. All right, so we know that we're starting from Q. Great. How are we going to now determine the bearing of the angle of P from Q? The bearing of P from Q, sorry. Beyonce, over YouTube is where you get A from, sister? There is absolutely no A in the question. All right. So, okay, we know where we're starting from. So what's the bearing, students? What's the bearing? What's the bearing? How can we determine the bearing from the information that was given? Don't only look at the diagram, look at the words as well. All right, Beyonce, I forgive you. I don't see no answers forthcoming. What's happening? Any answers over here on Zoom, miss?
So Kayla is saying 120 degrees.
Kayla, just so? No, man. I know how we roll.
So Shane is asking, are we going to be using the sign in the sign rules? That Michael did respond by saying we're going to be adding 66 to 54 to get 120 degrees.
Okay.
And Dana is also agreeing, but Dana inserted the 0 and 66 to ensure that it is 3 figures.
Thank you, Dana. Love that for you. All right, let's see. So, as you rightly said, remember the name, we are going to be adding that 54 degrees to that 66 degrees to get 120 degrees. Again, students, you want to look at all of the information that is given in the question. So on the diagram, the 66 degrees was not inserted. However, it was said in the body of the question. So you want to ensure that you are looking at all the information that you have been given. Okay? All right. Next question. From a harbor H, the bearing of 2 buoys, S and Q, are 185 degrees and 311 degrees respectively. Q is 5 4/10 kilometers from H, while S is 3 5/10 kilometers from H. On the diagram below, not drawn to scale again, guys, don't take out a protractor and measure any angles, which shows the sketch of this information insert the value of the marked angle QHS. So before we can insert the value of the angle, we have to determine what's the value of the angle QHS. Now, QHS, the angle QHS, where is that located? Which of the letters would that angle be formed? Would it be Q, would it be H, or would it be S? Which of those letters should I be inserting my angle value? Great. I'm seeing H. Excellent. But as you can see, there are quite a few angles being formed at the point H. So where exactly? Miss, can you demonstrate using your cursor where exactly the angle QHS would be formed, please? And I'm seeing Micah saying in the triangle. Fabulous. Thank you, Micah. All right. And I want to be honest with you, students. When I first looked at this question, I didn't read the question properly. And I found, Miss, I wanted to indicate the angle that I initially found when we were discussing. I did not look at the angle inside of the triangle, honestly, and that's because I didn't read the question properly. But I was trying to calculate the value of the angle that doesn't have that turn, right at that north line where the arrow is. That's the angle I was looking at, and that's because I didn't read the question properly. And so I don't want you to make the same mistake that I did. And so you want to examine your diagram and ensure that you read the question properly, right? So we know that the angle QHS is that angle at H formed inside of the triangle. But what is the value of that angle? What is the value of that angle? Nico, you're asking me or you're telling me? I see a question tag beside the answer, or you accidentally put that question tag instead of the degree sign. Is that an accident, Nico? And that's okay. We're gonna figure it out. But how would you have gotten that 180 degrees though? Look here, Kayla, don't follow. How are you getting that 49? We want you to tell us how you would have gotten to the figure that you would have gotten. Ryan, how did you get that 170? Ryan, sorry. How did you get that 175?
I'm going to remind the students that when you get a question, it's best to insert all the known numbers first, and that will give you an idea of what to do or what operation to take should be taking place. So look at all the numbers in the question, insert all the angles, insert all the lengths, all the distance traveled, and then that will give you an idea if you need to subtract, if you need to add, and what are you adding or what are you subtracting from.
No takers on YouTube. What's happening? I'm not seeing any answers. What's happening, YouTube? You gonna leave me? trying to figure out what's the value of the angle QHS.
I'm going to remind you of the question again. It's saying that you are coming from H and the bearing of two boys, S and the Q. So you are coming from H. So look at the question. You're coming from H. So maybe you made your first stop at S and then you went on to travel somewhere else. Or you could have done a journey from H straight to Q. Think about it like that. Shane, tell us how you got your response. Shane is saying 126 degrees.
All right, so on YouTube.
So Shane did respond, but he wrote it. He's saying that, and I'm going to just correct it. Shane, you're saying that you're taking 185 from 311. So I think you should start with 311 first when you're writing, but I think I understand what you are saying. Remember, you start with the 311 first, followed by the other number.
Razim Harvey on YouTube, how did you get that 120 degrees? It's not tough, man. I said that, it's not tough, man.
So I have a few more responses. Rayan is also saying that you should be taking the 185 degrees from 311. But please remember that you're starting with the 311 first when you're writing, Rayan.
Or if you even start with another number, if you're starting with 185, you certainly can't end with a positive value if you're subtracting 311.
Ashanti is saying 136 degrees and Nico is saying 126 degrees.
All right, I am seeing on YouTube, take away, McFarlane, something missing from take away 100. Okay, you deleted that. Okay, so it's 300. I'm seeing Shanoya Jones saying 311 subtract 185, which is equal to 126. Where 126 what, Jones? Dumplings? All right, miss, let's show them what's happening. So as you can see, that movement from H straight to Q would be 311 degrees. And we also know that the movement from H to S would be 185 degrees. And so if we want to know the angle QHS, that would be 311 degrees subtract 185 degrees, and that would give us 126 degrees. Excellent job for those who would have gotten that value. And keep trying, those who might not have gotten that. Be not discouraged. All right, so If the bearing of Norwich from London is 042 degrees, what is the bearing of London from Norwich? And we spoke about this earlier. If the bearing of Norwich from London is 042 degrees, what is the bearing of London from Norwich? So if this was a multiple choice question and they didn't give you any diagram, how would you determine the bearing of London from Norwich? Alrighty. Any responses, miss?
So I'm seeing Kayla saying 222 degrees, and Dana is saying that she'll be subtracting 042 degrees from 180 degrees to get 138 degrees.
All right, let's see what's happening. So the bearing of London from Norwich is actually 222 degrees, and we would just simply add, as I'm seeing Rayan said, 180 degrees to that 42 degrees, using that backward idea we spoke about earlier. So if the bearing of Birmingham from Dover is 300 degrees.
Latoya, Nico is asking why addition.
Okay, Miss, would you like to take that one?
So remember that we had said before, Nico, that to get the return journey, you would add or subtract 180 degrees. So if you went in a turn of 042 degrees, that means that you're going to be going back somewhere. So that means that the angle falls between 0 degrees, 0 degrees, and 360 degrees. And you want to make it, let it fall within that range. So if you subtracted, you would have gotten a number that doesn't fall within that range. So therefore, you would have to add. If you look at it in this sense, it must fall between 0 and 360. This number is 42. Would you add or subtract? Because you want to fall within that range. So if you understand that, put in the answer for the other one below. And tell me why you would do what you are going to do.
So just to reiterate, there are some very key points that we have to remember when we're looking at bearings. One, we start at a north point from north, yes? We only go in a clockwise direction. We represent our bearing with 3 figures, and our bearing must lie within the range of 0 degrees to 360 degrees. So if it is that you're calculating the bearing of a point from another and you get a negative number for your answer, it means that you would have done something wrong because it's not falling within the range of 0 degrees to 360 degrees.
And based on his understanding, Nico said he would now subtract for the second one and he would have gotten 120 degrees. Very good, Nico.
All right, let's see. Excellent. Fabulous. Great.
So once you would have done and understood how to find the bearing, I remember a question was asked before, would I use a sine rule? And for these questions, you have to have an idea of what you have. And before you can answer any of those questions, you must know a few of these things. One, you must know the three applications in trigonometry. You must know Pythagoras' theorem. You must understand the three trig functions, the sine, the cosine, and tangent. And I think you all know me saying sine, cosine, tan. You must know that. You must also know the sine rule and the cosine rule. And when we say know, we mean you should know when to apply. We're not going to ask you to memorize any of the formula. What we are asking you is to just to know when would I apply the formula. So let's see if you have any idea of when to apply the formula looking at these pictures. So you have four images, they're all triangles, different type of triangles, and you're going to type in the chat, and I want all the answers at once. So before you start typing, look at all four of them, and then you're going to put your response in the chat, and then we are going to go through and see if your answers are correct. So how would you determine the unknown measurement?
Micah, you said Pythag, but for which number? You want to indicate which of the numbers, which of the triangles are you referring to? Yes. So you can just say 1 or 2 or whatever, and then put the response beside that number. So I'm seeing Pythagoras theorem for number 1. Quite a few persons said that. So what about numbers 2, 3, and 4? Remember, we're taking all the responses at once, and then as we go through, you can see if you would have been correct or not. I'm seeing sine rule for quite a number of persons for number 2. Jesse, Ashanti, and Micah is saying the sine rule for number 2. On YouTube, I'm seeing number 1 for Pythagoras theorem. What about numbers 2, 3, and 4? Jesse is saying cosine rule for number 3. So too is Shane. Micah is saying cosine rule for number 4. Kyla is saying sine rule for number 4. Kyla and Ashanti is saying sine rule. So Micah is saying cosine rule for number 4, but Ashanti and Kyla are saying sine rule for number 4. So let's see. On YouTube, I'm seeing sine rule for number 2, cosine for number 4. All right, let's see what's happening then, Miss.
Let's go through and see if what you are thinking, we're also thinking the same thing. Let's look at the first one. So you have a triangle. Could you indicate the type of triangle that we have? You answer in the chat. Tiffany, hand is up. Hi, Tiffany.
I'm seeing right angle in the chat, Miss. Shane and Micah is saying right angle.
Okay. So if I say right angle triangle or right triangle, it's the same thing I'm referring to. So some books might say right triangle and some books might say right angle triangle. They're referring to the same triangle. So we have a right angle triangle and we are given 2 lengths to find another length. There's no angle involved. So we will automatically use, and let me see which person did give an answer, Miss. Let me just take one from the chat.
For what?
No, number 1.
Number one, oh, I think I went too far in my chat. I think Micah did say Pythagoras theorem and Shane.
So, Micah, could you tell me why you said Pythagoras theorem for this one?
Also on YouTube, Chanel Gardner did say Pythagoras theorem. So
Maybe.
you can type in the chat why you are saying Pythagoras theorem for number one. So Micah is saying that it is a right angle triangle and you have two sides.
So you are right, but you missed one. So you are indeed correct, Michael. It is actually Pythagoras' theorem, and there are a few things that you need to know when you are applying the Pythagoras theorem. One, it's a tool used for only right triangle problems. So if the question is not a right angle problem, if there's no right angle form in the problem, you cannot apply Pythagoras theorem. Also, as she said, you were given two lengths. So when you are, number one, if you are speaking about, and the questions involve a right triangle, and you are given two lengths, and you need to know the third length, you need to apply Pythagoras' theorem. And Pythagoras theorem states, somebody type that theorem in the chat, please. What the Pythagoras theorem states. It is the only one that you need to memorize because it is not on the formula sheet. So you have to remember this one. This is the only one I'm going to ask you to write because all the others will be on the formula sheet. And all you need to do is to lift that formula when you're applying that formula in the question.
All right, so I'm seeing Ashanti. I'm going to assume that is square they're saying Ashanti. And Ashanti has a squared equal b squared plus c squared. Dana is saying a squared plus b squared equals c squared.
So based on how this diagram is labeled, which one would we actually use? So it can be a square equal to b square plus c square, but based on how this triangle is labeled, which one is the correct one that we are going to use for this particular question? Is a square equal b square plus c square, or c square is equal to a square added to b square? And Shane is saying anyone. But if you choose anyone, what would my C be? And how would you know where to start? The question is, if you are using this triangle as labeled, would you use the formula a square equal b square plus c square, or c square equals a square added to b square?
I think somebody said actually a squared is equal to b squared plus c squared.
Oh, yeah, because what I'm saying, it can be written that way, but it's based on how the triangle is labeled. So which part do you call B? What is B? So what length would be B? Based on how my triangle is labeled, would you refer to the B right here? So based on the formula, each length has a particular function. So would it be B you're starting with, which is equal to a square added to c square based on how the triangle is labeled?
Shane is saying that the adjacent side, B is the adjacent side and A is the opposite side.
And C is called the
I'm also seeing Micah saying that C squared subtract A squared is equal to, I'm going to assume you're saying B squared, Micah, and not just B. So there's a thank you, love. There's a subtraction going on there. Shane is saying that C is the hypotenuse. So too is Regina and Nick.
So let me just clarify. And many students label the triangles differently. Teachers label the triangle differently. So some might start with A on this side, some might start with A at the bottom. But you start the equation based on one thing and one thing only, which is what we do. And this is the one that we start with. This is called, the longest side is called the hypotenuse, as Nico said. So if you're going to label your triangle and the hypotenuse is C, you have to say C squared is equal to A squared plus B squared. If you label your hypotenuse as A, because you can label it any way you want, that's your choice. But if you label your hypotenuse as A, you have to say A squared equal to B squared added to C squared. So although you told me your answer was B squared equal to A squared added to C squared, you have to now know that A, which is the length of the hypotenuse. This is where, that is a skill that you have to learn. When I label my triangle, I could say that hypotenuse is A and someone else could say it is B. But when I'm applying my formula, I have to say the hypotenuse squared is equal to the square sum of the other lengths. So it has to be that you are now knowing that hypotenuse is what we start first or at last, but you have to say the other two lengths are square and they're added together to give you the square of the hypotenuse. So if I label it this way, I have to write my formula this way. So I'm saying it that we square the lengths and we add them together and we end up with the square of the hypotenuse. And I'm going to say it again, where A and B are the legs of the right angle. So it's what you need to know. A and B has to be the length of the right angle. So it doesn't have to be A and B. It could be whatever letter you chose to assign, but these two have to be the leg of the right angle, and the one by itself over there to the right-hand side is the hypotenuse. This is the only formula that you need to memorize because this one appears also in coordinate geometry and it might appear in a measurement question that you need to apply. Let's look at the other one. That's number 2, and I think I had a few answers, and a few answers were saying the sine rule. And could you give me another answer, Miss, for the person who said the sine rule? Could you tell me why you said the sine rule?
I think all persons who responded to question 2 would have said the sine. Oh no, on YouTube somebody said sine. Montana McLean said sine. I'm assuming that's the sine function and not the rule. So Montana, if you want to just type and tell us why you're saying sine there. But I think on Zoom, the persons who would have responded to number 2 would have said sine rule.
So if you are saying the sine rule is different from the sine ratio. So I'm wondering if you are talking about the ratio and not the rule.
Ryan, sorry, is actually saying, and Shane too, is saying sine. So why are you saying sine, Rayan and Shane? What caused you to choose sine? And I'm seeing Shane saying it's opposite divided by hypotenuse. What does that mean, Rayan? Opposite and hypotenuse, what does that mean? So Ashanti is saying the reason is because you were given a known length and an angle. Shade is saying because there we have the hypotenuse length and the angle opposite from the missing side.
So in fact, based on what you said, we are using one of the trig functions. And the reason why I was asking, when you are saying the sine rule is different from the sine function or the sine ratio. So because you are given an angle, and based on the diagram, it's a right angle triangle, you are given an angle. And when you're looking at the question, it only relates to right angle triangle problems only. So if you look at it and a right angle triangle is formed, you can apply the ratio. But you have to apply the ratio when you are given two lengths and you're asked to find an angle, as the question above states. So you can be given two lengths and you're asked to find an angle, or as the question above, you might be given a length and an angle and you're required to find another side. So therefore, to do the trig ratios, you have to be given a right angle triangle and you have to be given a length and an angle to find another length, or you are given two lengths to find another angle. If there's no angle and you are asked to find something else in a right triangle, it means that you are applying Pythagoras' theorem. And as you said before, you would have used a sine ratio, and it is based on what you are given. So when you made a reference to the opposite and the adjacent, it's based on how the triangle is labeled and your reference angle. So our reference angle is formed at A, hence you would see the formula sine A. The reference angle can be formed at B, and you will write sine B. This side in purple is always your hypotenuse, but the other two signs change based on one thing. And how can we identify the adjacent and the opposite side? In the chat, please indicate how would I determine which length is the opposite length and which length is the adjacent length. If you're given a question, how would you determine which of the length is opposite and which one is adjacent?
Shane is saying that opposite is always the other side from the angle. Micah is saying length opposite of the angle is the opposite length. Oh, it's moving so fast. The opposite is the opposite to the angle. Which angle? The length that is opposite of the given angle.
It might not be a given angle all the time. It could be an angle that is unknown, so we call it the reference angle. So it might be known or unknown, but once you're referring to it, it is what is opposite. So the angle might not be known all the time, but once you're referring to that angle, it would be what you are saying. How would you find the adjacent? So what would you just take a look at it just to see this is my adjacent? Any quick tips that you can give to somebody to say, look at it, and now you know it's the adjacent length.
Shane says, oh, no. Sorry, I think that was an old message. Dana is saying adjacent is the side which both the angles are resting on. Ashanti is saying it is the length that which the angle rests on.
Which is right. So when you're looking at the reference angle, Once your reference angle is always formed with the hypotenuse and the adjacent length. So you are always forming an angle with the hypotenuse and the adjacent length. So it's, as you say, resting on. So it is there. The arms of the reference angle or the legs are always the hypotenuse and the adjacent. That's what you use to make reference to. And the other one would be your opposite. So once you have those ideas, you can now select the appropriate ratio. And the ratios that you know is the sine, which is the opposite divided by the hypotenuse. So once you know what you have and what you're asked to find, you can now select the appropriate ratio. And cos A would be equal to the adjacent divided by the hypotenuse, while tan A would be equal to the opposite side divided by the adjacent side. So when you go into the exam, you have to write down what you are given and what you're asked to find. Based on those criteria, you now select one of these. All of these ratios are on the formula sheet and you're not required to retain. You are only required to be able to select the appropriate formula, then you do your substitution. So remember, you use based on the question, can the sine rule be applied in the question above? And who knows what the sine rule is? You were saying the sine rule before, and as opposed to the sine ratio. Because there are two different things. Do you know the difference between the sine rule and the sine ratio? And can the sine rule be applied to the question, to this question above? Look at the question, take a pick, and based on what we go through, you can tell me if the sine rule can be applied to this question. So take a few minutes to look at the question, or take a pick, and then we're going to figure whether the sine rule can be applied to this question based on what you said. So question number 3, here we have a triangle, and the triangle is different from the one that we had before. This triangle is not a right triangle, and we are given a few things. We are given 2 lengths, an angle, and we are asked to find a missing angle. But what 2 lengths are we given? What we are given is one opposite side or angle pair and something else. So when you look at the question in the diagram is going to be drawn, or you're required to draw the diagram based on what you're looking at. Am I given an angle that is facing a side? So this is what we call our angle pair or opposite side. So the angle is here and the known angle is facing the angle, so it's opposite. We are also asked to find an unknown angle, and also the opposite length is also given. Once you have that pair of the first pair of opposite sides or angle pair, you can apply the sine rule. So does anybody know what the sine rule is? Could you type the sine rule in the chat, please, if you know what the sine rule is? So if you know what the sine rule is, you can say yes, and if you don't know, you text no in the chat. So Michael knows and Ryan knows what so you are saying kind of. But we're going to be going through it because you need to know what it looks like. So Michael is saying sine A divided by A is equal to sine B divided by B. So once you have that pair of the angle and a length, you can apply the sine rule. Because in referencing, remember you label your points in capital letters and you label your sides in common letters. That is why it is important to label first so that you can make reference to your lengths. Let's look at this one. But let's look at what we have. And for the persons who responded to this question, tell me what your answer was again and why did you choose your answer?
Some persons said sine rule, but I think most persons said cosine rule.
And why did you say cosine rule for the ones who said cosine rule? I think Micah is saying to me the angle is between the two given lengths, and that's why you chose the cosine rule. And that's one key thing that you have to be able to see, to select by looking at what you have. So for these questions, you have to be able to just look at it and be able to see what you're being asked to pull, or which formula you're asked to pull from the formula sheet. So based on what Micah is saying, these known lengths are given and it is used to form an angle, and the angle is given. So you have the arm. So in fact, you are using the cosine rule, and you have two sides and including the angle. So you have a corner. So you have to be looking for a corner. So the corner might be known, or there might be an unknown in the corner. So if the corner is known, you're using the cosine rule. If you're asked to find something from the corner, it means you're still applying the cosine rule, because one of the corner, the angle in the corner can be an unknown. So once you're given a triangle, a non-right triangle, and you have a corner, whether you know the angle or not, you can apply the cosine rule.
Just to reiterate, Miss Dana is asking, when is it that we use the sine rule?
So when you use the sine rule is when you have a pair. So you can apply the sine rule here because you have a pair, but what would you be asked to find? So if you have here and a pair, would you know anything else to use it? So let me go back for the visual. So you need to look at the visual. You have an angle and you have something opposite to it. So you have a pair, and the pair is always something, the angle opposite, and the angle and the opposite length. You are given that, and then you are asked to find something else. Sometimes you can apply the angle. If you're not asked to find this angle, but you're asked to find a length, you have to apply the sine rule twice. So you can apply the sine rule once you have a pair with an angle and an opposite length. So if you go into the exam and you'll see where the arrow is drawn for you, the angle and the opposite length, once you have anything looking like that, you can apply the sine rule. For the cosine rule, once you have a corner, you can apply the cosine rule. And the corner, lengths are known, and the angle is known, or the angle might not be known. Like this one, the angle is not known, but you know all the other lengths, you can apply the cosine rule. So the CSA question that will come up, you have to be able to look at it and figure out when to use it. So applying the cosine rule. The rules for reference here, we are doing the rules. The rules are applied to all triangles. However, to make it easier for you to remember, when you see the non-right angle triangles, you can apply the rules. So you can apply the rules when you're the non-right triangle, just for ease of reference, but it can be used for other triangles. Let us see if you can just, based on what we did before, test your knowledge to see if you would have gotten what I said to you before. Use the words and also the images to give your brain the idea. It might be easier for me to look at the picture, or I prefer to read the words. So the first one says you have two angle sides opposite pair, and you want to find the missing angle or a side in one pair. Diagram is over here. What does it look like? Would I use a sine rule or a cosine rule? Put your answer in the chat. First one, two angle sides opposite pair, missing angle, or one side in one pair.
Regina is saying cosine, Dana is saying sine. I'm seeing sine rule on YouTube from King Orthodox.
And why are you saying sine rule? Just to ensure that you understand when to use a sine rule.
Cosine rule from Rayon, sine from Ashanti.
Anybody saying why? Please type why so you can cement that concept. Anything in the chat, miss?
Shane is saying because you have a set or opposite side to an angle.
Because you're that pair, very good. So you're applying the sine rule. Number two sides known and a missing side opposite a known angle. And you're asked to find the remaining side. Look at the words, look at the image, and just by looking at it, I want you to be able to tell me which one you will use.
I'm seeing cosine rule from Shanice on YouTube, cosine from Micah and Rayon.
And tell us why quickly when you type the answer, explain why so we can cement that concept. So I'm seeing where somebody saying because there's two squeeze, because the two sides and the angles together, I'm saying you're saying side, only one pair given, only one pair is given, so it cannot be the sine rule. So it is in fact the cosine rule because as you said before in the chat, let me see who said it. Because you have a complete corner, right, Regina? There's a complete corner that is known, so you can apply the cosine rule. And for this third one also, all angles, all sides, and an angle is known, so therefore you're applying the cosine rule because you also are given all three sides and an angle is you're asked to find an angle. Let's look at the last one. Two sides are known and a missing side, not opposite, known. And you have to find the remaining side. What would you do?
I'm seeing Taija. I'm so sorry if I'm mispronouncing your name there. She's saying tan.
When do you use the tan ratio?
And are you saying tan ratio or tan rule, Taija? Ashanti is saying trig ratio, which of?
Please remember that the ratios can only be used when you have a right angle triangle. If you look at the triangle here, there's no indication of a right angle. So you have to now remember, if you are doing the trig functions or the trig ratios, it can only be applied when you are using or looking at a right angle triangle. If there's no right angle triangle, you have to now pull up one of the rules. So if you look at it based on what you are given here, although, there's something in the chat, Regina is saying sin, but we're not, is it sin ratio or a rule? They are different things. You have to be specific. Is it the sin ratio or the sin rule? Ryan is saying the cosine. Based on what it looks like, a couple of things cannot happen. You have to know to use the cosine rule. It has to look like the ones in 2 and 3. So if it's not looking like 2 and 3, although you are given the 8 and the 6 and the 40 degrees, the arm formed with this 40 is not known. So you cannot apply the cosine rule You have to have the corner, the length has to be known, but the angle could be asked or it could be known. So it cannot be a cosine rule. It means that we have to apply the sine rule twice. So in some questions, you have to apply the formula twice to get unknown to be used elsewhere to find the unknown, which is right here. So some of the formulas will have to be applied twice. You have to go find something that you want to get to what you are asked to answer. Some question take a 2-step or a 3-step, and the last one here, because of what you know, the arm of the angle is not known, only one leg is known, you have to apply the cosine rule. Do you have any questions? How do I do that? How do I apply the cosine rule twice? So if you look at it, you're asked to find this length with the question side. It means that you have to know the angle of the opposite side. So if you know the angle of the opposite side, that means that you would now know that the third angle by doing something. So this is like a 3-step problem. So this is what will happen. You apply the sine rule using 40 degrees and the 6, and you apply with the 8 and the opposite angle here at the bottom, which is unknown. Once you find this angle, you will know what the angle is up here. Want to know the one up here by subtracting? How would you, and what would we subtract to find the missing angle here? So if you know the angle down here by applying the sine rule first, you will know the one here. And then you would apply this angle with the unknown length with another pair, which is applying it twice. So it requires 3 steps, not even 2. The sine rule, doing an up to find the unknown angle, and then you will now subtract to find the third angle, then you apply the sine rule again to find the unknown length. And it have to be applied twice. For those questions, it's just a visual. If you take a pic of this screen, it will give you a good idea of when to apply the formula. So if you look at the number 2 and 3, the distinct look, the corner, and the angle is known or the angle is unknown. If you have a opposite pair, you can apply the cosine rule, the sine rule, but you might do the sine rule twice, depending on the question or the unknown side. Another thing that we have to look at when you are doing the formula, we're not asking you to just to retain the formula. The formula will be on the formula sheet, but a key step is to be able to label your sides. You are given this triangle in exam, you will do what have anything on it, but you are now required to apply this into a formula. The formula is here. This formula is on the formula sheet. So we're going to label the triangle. And how do we label the triangles? We label the triangles. We label the triangles. So you label the angle first with a capital letter. And then the sides are labeled with a common letter and they are related to each other. So the angle is capital A. The opposite length is a common A. And then you label the others B or C. Let's go again. So if you label the angle A, capital A, the opposite length is common A. And then you label the other lengths B or C. So the formula normally starts with a letter. It goes again, if you start with a common A square, you have to end with a cos capital A. If you label your angle B, you have to start with B square is equal to A square added to C square, and then you change these two letters inside. So some books might say C square is equal to A square added to, so C square is equal to A square added to B square, and then minus 2AC times cos, and the cos here is depending on what you start with. So if you start with common letter A, you end with a capital letter A. If you start with a capital letter, common letter B, you will end with a capital letter B. So it doesn't matter how you write the formula. Once you know that your angle is capital letter A, you have to start the formula with this. So once you know how to label the triangle, you can now substitute. You have known all the lengths and known the angle. So let us look at it. The A is unknown, so you will say A square is equal to B square, which is 15 square, added to 12 square. And then in exam, if you are not comfortable with doing it in one step, we advise to take it in stages. So you can do on your calculator, 15 square, added to 12 square, and you write down your answer. Then you put your subtraction sign, you open your bracket, and then you go again for this section here. On your calculator, please note that some of them you have to type in the cost first or the cost after. Know your calculator before you go into exam. Know the function so that when you go into exam, you know whether do I press the cost first or the cost after. Once you know say, and whatever numbers are here are the same numbers that come here. So you don't have to think about it. Once you put 15 and 12 here, 15 square, it is the same number that come back in the bracket along with the 2 multiplied by 15, multiplied by 12, multiplied by cos 115. Plug this into your calculator and you would get this answer. So I'm going to give you a few minutes just to check your answers on your phone or your calculator. But I would prefer your calculator since you would not be allowed to use your phone in exam. Just to ensure that whatever you do, you would have gotten this answer. So you would have tested to see if you know how to put this operation in your calculator. Once you are finished, just give me a thumbs up in the chat and then I will continue. Remember, sometimes, although you're online school and sometimes you don't have to do it, remember, it's actually a physical exam that you're doing. So it's good to just to check to see if I understand. So I'm seeing Shane saying thumbs up, so Shane would have gotten the answer. It's good to test to see if you understand it so that you can say, I know this concept now, and I'm going to go on to a different concept when I'm preparing for exam. Awesome, Ashanti. Please realize that in the third line, it is after 5. In the third line, we have 5 decimal places because we want the answer to be 2. So Shane is asking for the PowerPoint. The recording will be in the on YouTube, so we can go there to review the answer. Also, if you are given the unknown angle, you can use it. So the unknown angle is here, and you label again. So that means you start with by labeling A. This is the unknown angle. So that means you have to now identify the opposite side, and the opposite side would be, based on what we have, A squared. So this is the opposite side. Substitute correctly in the formula, and because you're asked to find cos A, you're asked to find an angle, the cos A would be what we need to apply your inverse. So you need to apply your inverse on your calculator. It means that you need to know how to find the inverse on your calculator. So that's what you need to be checking also. How do I find the inverse on the calculator? So a question is in the chat from Secretary class, should I use this same link?
You'll have to use the link that was given to you there.
All right, so please remember, when you're given this problem, you have to choose the right trig formula. So based on what you have, if it's Pythagoras, it's a right triangle, you're only given lengths. If it is a right triangle and you're given an angle, it has to be one of the ratios. If it's a non-right angle triangle, pull one of the rules, substitute, and then you solve. Use the question paper. So I suggest that you go through the questions. So see the question on the paper, read the question through. Look at what you are given, and then you know, read question 1, read question 2, read question 3. Based on what I am seeing, what do I need? Go pull it from the formula sheet and put it on the question paper at this point. Don't wait until it is time. Put it on here, so don't squat it. Go back, scroll the paper to the front of the booklet, copy the formula on top of the question, and then you start the question. And it says, a diagram below, and remember, it's not drawn to scale, shows the relative positions of 3 reservoirs, B, F, and G, on all on level ground. The distance BF equal 32 kilometers, and it is inserted here from B to F. It's on diagram. F to G is 55 kilometers, and an angle BFG is 103 degrees, and F is on a bearing of 0.42 degrees from B. So here you are asked the first question to find the bearing. This is always the first question that was taught by Latoya. You have to do this part first. It will determine what you do in the next part. So look at the question and tell me your answer. So put your answer for the first part, determine the bearing of B from A. And when you put in the chat, tell me where you are and where you are going. And then do your calculations. And this is where you need to be writing. Although you're online, you are now checking to see if what we did together, you would have understood.
And just in case you are, you're not able to write so quickly, all the workshops will be saved on YouTube, and you can always go back at any time and watch the presentation. So they will always be there for you to go and look at. Okay, so saying going from F to B.
So insert the calculation, insert the process and your answer. Any answer in the chat, miss?
No, ma'am.
Remember that when Miss Latoya was speaking, remember, if you're coming from B, you have to insert something there. So when you're going to exam, anything that is missing from what you know needs to be in it, you have to draw it on the diagram. So something might be missing from the diagram, you have to insert that thing that is missing from the diagram. So if you're coming from F, something must happen. You must be coming from somewhere. Where are you facing? You're facing somewhere, you are turning in a clockwise direction to somewhere. So you have to now put in that thing that you are coming from or you're facing. So something is missing from the diagram, you have to insert it and then you can calculate. Because the answer is in the diagram, we can use that diagram to give you a mark if you insert it. Anything on YouTube?
No, ma'am.
All right, so let us see what we have. So the first question, remember, because you're coming from F, the first thing you have to do is to insert your north. And that's why we did before, show you how to draw, because that's one of the key things that you have to be able to do. Insert your north lines, and then you are coming from F and you're going to be in a clockwise direction. All right. So we now apply two things. We say that the angle formed here and the angle formed here, we say there are turning angles, so we know we know what the bearing is. All right. So if we know what the bearing is here, we can now do two things. Find the bearing, which is this one, and now we add it to the 180, and we get 220. So although we would have gone into the exam, if you are not sure, you are not going to write anything. So sometimes we go through the process. When it's time for us to execute, we are doubting ourselves. So if you see the question doesn't look like what you know based on what was taught, you have to put in something for it to look like what you normally see in the classroom, all right? So the other question says you are asked to find BG. So based on the diagram, BG is the length B to G. Based on the diagram, what would you use? Would you use Pythagoras? Would you use a function, or would you use a rule? And if so, which one would you use? So this question is now asking you, find me a length. It's a triangle. Look at it and just indicate which one would you use. You cannot do this in exam. That means you won't able to do this question. Just by looking at the triangle, tell me which one would you use.
I'm seeing Ashanti saying sine rule.
Anyone else? Remember, when you are using the sine rule, you have to have a pair, or you're given a pair.
Dana is saying cosine.
So remember, that is why we show you a visual. Look at the visual. You have to take a picture of the visual. You are given, it's on it, you are given the corner, which is 32, 103, and 55. So even if you got part A wrong, you are still given something that you know. Look at it. You are given a corner and an angle, and you're asked to find opposite sides. So you're applying the cosine rule. Don't sweat it, just go for it. You know it. So your job is to know, write the formula from the formula sheet, label the diagram based on what you're told, and then you insert it. Look at this one. I have C squared. And the other one I had before was A squared. It doesn't matter. Once you know that the angle is C, that means right here is C. The angle that you're asked to find the length you're asked to find would be a common letter C. And that's all you need to remember, which is BG. And BG is unknown. So you substitute 32 square added to 55 square, and then you subtract 2 multiplied by 32 multiplied by 55. These two numbers would come back here automatically. Don't think about it. Then you write the word cost, and then you write the angle based on what you have in the question. And then you go into your steps. Step 1, step 2, step 3, whatever it is that you prefer. Once you write it back correctly, you can do it. And it did say, put your answer to 1 decimal place, so you have to do that. Ensure your answer is to 1 dp, because what is stated, you will be asked, you'll be given mark for this process. All right. So your key step is being able to know when to use a formula. And let's look at the last one. We're gonna move on to another question. This is when you apply the sine rule. I'm gonna go through this one, and then you're going to attempt the other one. And all we're gonna focus on is just, how do I know which one to use? Based on what I am given, I am asked to find an angle here. Angle pair is known. So angle pair, the angle is not known, but you know the opposite side, and a pair is known here. So you apply the sine rule. So our job right now is to know which one would I use. So I'm going to go to the next question for you just to tell me which one would you use. So we're not calculating now, just tell me which one would you use. Diagram is here, and I'm going to go through to this one. So to be answering this question, you are asked to find a length AC right here. We're going to insert the numbers in the formula, and then we're going to ask you to just identify which formula you would use to find distance AC. I am going to insert the answer right here for the first part, and then you tell me just the formula you're going to use. So we're going to do the first part for you. And then based on the diagram here, look at it and tell me what would you use to find AC, and put your answer in the chat, please, based on how it looks. Tell me how would you find AC, and tell me what you saw that gave you an indication that you need to use AC.
So are we using Pythagoras theorem? Are you using sine ratio? Are you using cosine ratio, tangent ratio, sine rule, cosine rule? What are you using to find the length AC? Okay, I'm seeing cosine rule from Amoya Badal on YouTube.
Could you tell us why you are using the cosine rule so we can cement that concept?
As well as King Orthodox on YouTube.
Ashanti and Dana, tell me why you are saying the cosine rule, and Ashanti, tell me why you are saying the sine rule.
I think Ashanti's sine rule was from before.
From before? Oh, my sincere apologies.
Ashanti is the only one who responded just now to this question, and she would have said cosine.
So remember, if you saw the question before, it was not labeled, so you have to insert all the known lengths and all the known angles so that your diagram can come alive. So you can look at it and now know, what do I know, and what based on what I know and what I'm asked, which formula would I need to pull on to answer the question.
Shanice Williams on YouTube is saying cosine rule because the two lengths are hugging the angle. And King Orthodox is saying, he said cosine rule, and he's saying because you have two lengths and an unknown angle in the corner.
So you will know the corner. So what he said again, so the angles are formed. See it here, you know the corner. You have 52 kilometers and you have 72 kilometers. And the angle in here is known because you have two numbers in here, the 45 degrees and the 75. So those two will be added together and those will be known. So once you know these, 1, 2, 3, you'll be asked to find the unknown. That's the one skill that you need. So even though you're going to exam and you're thinking, know the rule, you know all the formulas, if you don't know when to apply them, you are going to be getting the questions wrong. So we're not asking you to maintain or retain the formula. We are asking you to look at the question and identify when do I apply the formula. So if you are asked to swap the formula, you're not given a mark for the formula because it is actually on the formula sheet, but you are given a mark to applying the correct formula. That's what you have to remember. There are the three profiles: knowledge, comprehension, and reason. So you have to know, get the higher mark, knowledge and the reasoning, the comprehension and the reasoning, because those are the higher marks, by being able to identify the appropriate rule to use. And the other part would be just knowledge in substituting those numbers correctly. So the main part of this question is being able to identify the appropriate formula. So I'm going to ask you, we have 2 minutes left, just to pull up your calculator and substitute the numbers correctly and put your answer in the chat, and I will check to see if you know how to apply these on your calculator, substitute correctly to get the right answer. So the first skill is knowing which one to use, and the other one is to substitute correctly. But the two skills you need to be able to do to get this part right. So the first step, look at the diagram. Looks a particular way. Once you have that, label it a substitute, and I'm gonna give you a minute or two to go through. Any answers in the chat?
No, teacher.
So students, though, although you come onto the platform, one of the things that I noticed that sometimes we say the right things, but we do the wrong things. So one thing you have to do, although you come to this channel and you answer and you speak, you have to actually physically do the process. So you cement both the thinking and the execution of that process, because the exam is actually a writing exam, not a verbal exam. So although you know it, you have to be able to apply it. So let's look at what we have. So I'm not saying the answer, so we're gonna look at it. I'm gonna go to the solution and we're applying the cosine rule, and we're gonna be skipping through that to another question here. You're asked to find the bearing of A from B. So based on this question here, you are asked to find the bearing of A from B, which is you are coming from C and you're going to A. So you have to insert that on it. And the sine rules are based on what you are given. So the sine rule, as was said in the chat before, you start with sine A divided by A equals sine B divided by B. However, what I'm suggesting is that based on what you're asked to find, you can flip the formula. So the formula can be flipped. So I think that, let me just show you, the formula can be flipped. So if you are asked to find the angle, unknown angle, like this one, it can be done this way. So there is no set rule. It can, because of the equivalence, the formula can be flipped. So what I'm suggesting to you, if the unknown is the angle, you flip it this way. And you have the sine at the top, A divided by A, which is equal to sine B divided by B. That is when you're asked to find the angle. If you're asked to find the sine, which is the length, you are going to flip the formula. That is why the important thing is not to know just what the formula is, know how to apply the formula. So you are flipping the formula. So right here, we did apply the cosine rule first. So we're going to apply the sine rule. So remember, the sine rule is on the formula sheet in a particular order. It can be flipped. So when you're applying the formula, if the unknown is the length, you will flip it like this. It's easier to do. If the unknown is the angle, you put all the signs on the top and all the lengths at the bottom, because of its equivalence, they can be flipped, and you flip everything. All right, so you flip the formula because it will be the same thing. Then you substitute and you do your transposition, and then you solve the question. Substitute and you find your inverse. So the important skill is to know how to apply the formula, and also when to apply the formula and substitute correctly. We have had a long day, and I think some of us have stopped talking. So tell me now, do you have any questions that you'd want me to answer quickly? If you have any content that you want us to deal with, you can send a message.
Not seeing any questions coming through. But again, students, if there's anything that you're unclear about, the video recording will be on YouTube forever. So you can always come back and watch or scroll through to find the portion that maybe was a little bit unclear and you need some clarity on. So I think that is it for today's session. Thank you so very much, everyone on Zoom and YouTube, for coming out today, spending a little time with us to go through bearings. Appreciate your time and your engagement.
Someone is asking the name of the YouTube channel.
The Ministry of Education. So you're looking for the Ministry of Education, Youth and Information's YouTube page, and they will be all under the videos section. So it's the ministry's YouTube page.
All right, so we are going to ask you to complete the evaluation form. We're going to place that
We're going to place the chat.
Yes, in the chat.
It is in the chat now.
Okay, awesome.
On Zoom. For those on Zoom, there's an evaluation form. It's just a one click and click quick. Nothing for you to, it's also on YouTube. It's also on YouTube. So just click on the link and fill out the evaluation form, please and thank you. We want to ensure that we are serving you as best as is possible. And so completing this evaluation form is very important for us. Okay? And so I think that is it from us. You can come back on Thursday at 3 p.m. where we'll be looking at circle theorem. So have yourselves a lovely rest of afternoon. Wash your hands, sanitize, wear your mask,